Yes, as I was saying, actually, I want to thank for the opportunity to let me speak in this event. Um, there's always a little bit of emotion and happiness when we take network observability more into as a first class citizen. So I'm gonna try to take this opportunity and make the best out of it. Let me see this. Okay. Well, a little bit about myself. Um, I'm a network automation observability engineer. I'm working in CoreWeave. My experience comes from different backgrounds on the network engineering side of things. Traditional network engineering from even starting as a network operations center over to projects management as a consultant as well. I used to work in network to code. If someone knows about the network to code as well, so I used to do consulting there as well on network automation and observability practices. And yeah, we're going to be talking about modern network observability. One of the few things actually, even working with Network to Go, was we did a lot of site surveys, talking with different clients about the current state of the network. And actually, this gave us the inspiration of actually working and talking, creating the book. We did a small talk at Cisco Live in Amsterdam a few years ago around network observability and where we are right now, right? And one of the few things is that the current network observability, or I would say maybe and we're going to be talking about observability monitoring in a bit, but is the fact that the current tooling that we have today is great. It's actually great for keeping the lights on kind of a scenario, but it's definitely limited, right? There are certain scenarios in multiple network environments, from a data center, which you actually need, up to the streaming telemetry aspect of things in order to get higher data resolution on network interfaces, all over to a more reactive, and more, I would say, speedy way of actioning alerts in a more intelligent manner. You might be buried with noise with a lot of alerts that your system is generating. So you want to put some intelligence on it, or some business context to actually understand what are the priority for all your alerts that are coming, right? And right now, in the current tooling that is supporting the network monitoring, is lacking some of these capabilities and flexibilities, right? And in today's, I would say, right now, I would say, is even more important the role of networks, right? From the backbone of the internet all over to the data centers, cloud providers, hyperscalers. We're working in a distributed compute environment where now not only the applications are ephemeral, that you may have an application that is running in one site and now it's running in another site, and you basically work with just a few switches, routers in order to have that data interconnected. You know the pattern of that traffic. When you're talking about compute like in technologies like Kubernetes on top of it, now even the infrastructure itself becomes ephemeral. Okay, your application is going to be moving into multiple clusters in multiple regions, and now that pattern becomes more hectic, right? So not only that, we also need, we're in the aspect of also having the need of having observability even at the I would say application level, right? You have technologies like eBPF, great for actually hooking into your applications and your stack on your infrastructure to be able to actually get even telemetry out and have some visibility and observability. And well, I work with CoreWeave, and CoreWeave is a hyperscaler on AI, and is even more important to have higher data resolution and analytics around this data. Okay. Now, I'm going to be talking about observability and monitoring in order to, I would say, demystify a little bit the two concepts, right? Um, for me, observability is maybe monitoring 2.0. Okay, it's nothing actually out of the normal, but a couple of questions actually help understand the difference between them. So when I talk about what happened, that's basically a monitoring. Okay, something happened, and the monitoring actually is telling me about the what happened. When I'm looking at observability, it's more around the why it happened. And those two questions actually um, gives you a lot of information of the difference between the two. When you look at the why happened, you are looking way more data than just metrics about your devices telling you that something is up or something is down. You're looking at insights from logging, from syntactic monitoring, or from even business context data that is actually being injected into your observability platform in order to get the context of what happened, right? And this is even more important in distributed architectures because you don't know where the issue might be coming from, okay? Especially if you're working in the interconnected world with multiple regions and multiple data centers interconnected with each other. Now, the problem with the current tooling, okay, there's I will start always with the vendor lock-in, and this is nothing against the vendors, by the way. This is basically the fact that when you're working with specific equipment, they tend to or create all the monitoring, all the capabilities toward that equipment, which is great. The problem comes with the networks are pretty much hybrid. Okay, we have different vendors, you have different systems that need to be injected, and try to capture or get all of these different diversity in your equipment into one system can be pretty hard, right? The other aspect is static dashboards, which is maybe a little bit plain, but the static dashboards comes with the concept of having the capability of you want to get your data and you want to be able to see way more than what your observability tool is going to give you by default, okay? And this goes from a power user perspective. You want to be able to access the data, for example, normal dashboards or around a NOC, you get a device view and you might get, environmental information, CPU, memory, fan, interfaces, BGP status, and so on, right? What if you want to see it across a fabric? What if you want to see it across a region, across multiple peers with certain connections ID? Then you need to start crafting these dashboards, right? So the flexibility is heavily needed on the when we're talking about resolving and troubleshooting, right? And one that I think it's something that the industry can agree on is flexible data collection. We have multiple standards, multiple ways of collecting data. Okay, SNMP still strong there in order for us to actually collect the data. It actually has the most coverage around monitoring and telemetry. GNMI, OpenConfig and Yang is actually getting there. Definitely, a lot of vendors are investing a lot in that aspect as well in order for us to get to some kind of a streaming telemetry. But still, not all the data is actually available on these interfaces. You still need to, in a lot of the cases, you still need to either access the device using REST APIs, for example, or even SSH and CLI parts in order to collect the information that you need, okay? So we're still on that aspect, which is kind of difficult with the current tooling, right? Because most of the time with the current tooling that I'm talking about is around SNMP. Now, this is a big one, and it's the missing of the context data. In observability, there's this concept around contextual data, which is basically a way for you to enrich metrics, events with information that is business specific, okay? For example, in this case, a device object may have information about IP address, serial number, and platform. You can get that from telemetry, okay? That is going to tell you even the model of the device. It's going to get you maybe some IP addressing if you do the query that way. But it's not going to have information about the role, who's the owner of the device, or what are the tenants of the device. And it's going to give information like circuit IDs. That information usually is stored in a source of truth system, okay? And I'm saying system, but it can be even a CSV file or Excel, okay? A lot of the conversations you may have heard is around source of truth. Over here, I put like the top ones that I know of, InfraHub, now about the Netbox, but it's actually any system or any data file where you actually have that context and business metadata. And why this data is so important is because this is what is gonna help you actually prioritize and get out of the noise that you currently are when alerts are being fired up from multiple angles. Okay, so what is a good way to approach this aspect? Traditional tools are often monolithic applications. They may have a lot of these components already that I'm actually putting out here, already developed in some form of microservice, for example. But one of few things, and working in order to code, actually, we found out that a lot of the monitoring experts that we um, had different experiences with different telemetry systems or observability solutions, I would say. Okay, some were really good and had really good experience with Influx. Others had, for example, my background has been on Elastic. Others have been really great around Prometheus and Influx, Grafana Labs, so Splunk. So there's definitely a wide variety of solutions around observability, and we pretty much came up with an architecture, a modular architecture, trying to depict what are like the key components of these solutions, right? So the first one that I'm going to be talking is collection. So data collection is what we already talked about, like the need of getting information from the devices. This is NMP, GDMI, streaming telemetry, telemetry dial out, logs, events, flows, synthetic monitoring as well. Processing and distribution is a layer that is kind of like at the middleware inside of an observability architecture, that the processing has a really important process, especially for large scale scenarios. And this could be enterprise, data center, service provider, that because of the different diversity that you may have in your environment, there is a need of normalizing the data, okay? And by we're talking about normalizing the data is the fact that you want to understand when an interface is up on a Cisco device, the same as an Arista device, the same as a PDU, okay? So these diversities that you have in your environment, you need to find a way to actually normalize it. And the distribution comes with the fact on where are you going to send this data, okay? Normally this is, it could be message buses, you may need it, you may not, but it's the concept of tying the data over to different backends, okay? Where you're going to be storing the data. So there's certain kinds of data like metrics that need to be stored in a time series databases, okay, in the storage level, okay? They're really good for storing numerical data, and they can provide some kind of algorithms for compressing it and make it really efficient for querying it. The logs are a different kind of data, and they're usually stored in log storage solutions. You might have heard of around Elasticsearch or Splunk. They're really great for storing that kind of information. There are new players in this field that are, I don't know if you have heard, but columnar databases, ClickHouse is a really popular one, but also there are solutions around Elastic and Grafana Labs that provide this in all this abstraction, okay? They just give you an interface for you to set the data in, and they actually are gonna deal with it on their own backend. Now, the last layer is visualization alerts, and they actually are a little bit different because in the visualization side of things, you have components that are really specialized on creating these dashboards, right? You need a way for you to collect the data from the network devices and visualize it in a way that is going to either help you troubleshoot or is going to help you around to create a report for someone. In the alert side of things, it tends to be decoupled on the observability because it also acts with another purpose. The kind of query that you do on a dashboard is not the same that you do on a query. So you have rules. There are different ways for you to create rules or create kind of, for query the data that is going to be able to set alerts for you. Now, what is the important aspect of things of these verticals around orchestration and social truth? They're there to help you give that business context and the setup necessary for building observability stack. Okay, they're basically like the missing pieces in order to tie all of these things together. Okay, well, we don't have enough time for a full demo, but if you want, reach me out. I actually kind of spin up the demo pretty soon, and we can actually see this live. But from this slide onwards, we're going to be talking about the specific POC or lab that we have on the book. That you can place on GitHub, you can deploy it, and it has some open source tools that actually give away some of the concept that we were talking about. But when the whole idea is to actually get a view of what are the benefits of using this kind of stack. The first one is correlation, okay? This is something that traditional systems is pretty hard to get to, like You either have the story with metrics or you have the story with logs, and you go into the metrics data source in the metric system, or you go to the log system. But with these systems, having different data sources, having the visualization layer decoupled, querying the storage itself, you actually have stuff like this, right? Like you can see here that we have metrics around the traffic over time of a specific interface. And these lines over here are called annotations, and they're actually just log events that actually are telling me either the blue ones are, for example, when someone actually connected to the device, when they enter configuration mode, and the red ones is when an interface actually started flapping. I just do an interface shutdown, interface up, okay? So this is the kind of information of correlation between metrics and logs, and we can start seeing how these things are playing better together, okay? This is the demo video, but I can show later if you want. The other aspect, and for me, this is the biggest one, is access to the data, okay? Traditional tools, they give you access to the events or alerts they generate, okay? But the data itself is really hard for you to get. You can sometimes you might be able to create a script in order to get the data on of the monitoring system, but you don't have access to the data that actually are collecting. And this is really important. Why? Because you might need to do other aggregations or other calculations that the one that the monitoring system is giving you. And you need to use that in order to create maybe higher level of alerts. And what I want to talk about higher level of alerts is they start talking about SLIs, SLOs, actually something that is more business centric, that is going to give you way more value than a bunch of interfaces firing up at the same time. Some of these interfaces might be up, might be down, you don't care. So those are the kind of things that the flexibility of having access to the data, you can start creating filters that actually matter on, and with the right context enrichment data, you can actually make them more valuable for you, okay? Now, on the automation side of things, because, well, I like automation a lot, but it's the aspect of that you can start scripting now on operational data, okay? It's no longer connected to multiple devices and give me the interfaces, give me the BGP status of what is actually happening right now. Now you have the access to what is actually happening right now from a database that have a really powerful, robust upstream API or query language, whatever you want to call it. And also you can get access to the historical data as well. You can see what are the trends. You can start creating more focused capacity management, predictions. So a lot of the tooling you start getting, and you can actually own it yourself if you want to, if you're a power user, but you can also leverage what is already deployed and developed by the community, because again, we're not the only ones actually using these systems today. This actually is really well-known systems that have been around for a while, and cloud natives and DevOps, SRE in general, have a lot of experience and have a lot of work with these kind of tools. And lastly, on the automation side of things, is event-driven automation, okay? This is actually the place where I hope our industry is actually going to get towards, right? It's actually maybe a North Star for a lot of people, but I'm here to actually tell you that it's not something that is out of grasp, right? And the main reason here is that there are different workflow orchestration systems, and the one that I have here is using Prefect. But there's tools like Windmill or Rundeck, Ansible, ADA, that actually have a lot of automation, workflow automation that you can actually define for yourself. That's going to help you either enhance a report for something that is faulty, or actually take a look at existing alerts and do some higher level of correlation, identify what actually matters and what actually is giving you the most noise. And also, start going into a self-healing aspect of things, okay? Interface flapping, for example, is an easy one to capture. So event-driven automation, I would say, is kind of like the next step around this, okay? So, well, this is part of the third demo, but, well, we have to talk about AI. I mean, today is we need to. So one of the few things for sure around AI is the aspect of the enrichment and the context that it can give you, that can help you troubleshoot, right? It can save you a lot of time and also a lot of resources for actioning on that specific issue. And this is actually just an example of a workflow in the book, and actually the lab also explains this a lot. When an event is generated, okay, you basically call an endpoint. This endpoint basically just calls this database that has an upstream API, and you actually are calling, well, for this device, I need you to get me the 5-minute, 15-minute, 20-minute logs. You have the data, okay? Then you query maybe your source of truth system in order to get information about that device. Tell me which site it is, what are the person of contact, what is the IP address, the role. Send that information, graph it up, put it into an LLM, okay, with a really nice prompt, and they can give you some really good information or initial analysis. And it can even give you, if you actually have information about the vendor, can even help you with some example commands or troubleshooting commands that you can actually act upon. So it's really powerful, that part, okay? And we're working more towards the use of AI in order to enhance or make ease of our operations, okay? So one of the key things actually to highlight is why some of these components and that you saw in the slides before and the basically the dashboards. The goal of especially the book is actually around open source and community. Okay, so there's a lot of value of showcasing how these different tools built from different vendors actually operate so good between each other. Okay, to give an example, we have a stacks that Telegraph can connect over to a Prometheus instance. It can connect to Grafana Loki. It can connect to Elasticsearch. The same, well, Logs and Telegraph is from the Influx community. Logstash comes from the Elastic community, can connect over to Grafana Loki, for example. Okay. Right now, there's a pretty good one that I actually want to highlight because I've been using lately a lot. It's called Vector from Datadog. They have a really powerful collection service there. It's built on top of Rust too. At the distribution layer, I'm saying Kafka, but it could be Kafka, NATS, any kind of message bus. And again, you don't need it. It's more around the scaling, the aspect of having a message bus. On the storage side of things, there are multiple. There's a lot of them. Prometheus is one of like the de facto of the CNF, of the Cloud Native Foundation. So definitely that's the biggest one that has a lot of open source contributions there. But it has evolved. There are different companies actually using like Grafana has Mimir. There's an open source Prometheus high availability system called Thanos as well. There's ClickHouse, there's Elasticsearch. So there are a lot of InfluxDB. There's a lot of different time series databases and not some time series, but they provide the same kind of support. The same for the log side of things. For logs, the market is less, but definitely we have really good examples there like Splunk, Elastic, Search, Grafana Loki. And from a visualization, there are others. So, for example, Elasticsearch has Kibana that is actually for the Elastic component, but Grafana can actually connect with everyone. And I think a lot of us have seen some kind of form of a Grafana dashboard deployed somewhere because it has multiple connectors and ways to query the databases. And on the alerting side of things, at least on the book, is using the Prometheus alternative, which is Alert Manager, and Keep, which is, it was a small startup that started working with an IT ops management system, but they've been acquired by Elastic, so I don't know what's going to be the future for them. But there's definitely multiple solutions out there like PagerDuty. Well, I was going to say VectorOps, but I think VectorOps is now acquired by Splunk. But yeah, there are others for sure. Okay. And I don't want to spend too much more time here on this slide. But the key takeaway was a best way to actually showcase different components from multiple vendors and how they can interact with each other. And between Prometheus and Grafana Loki is the querying language. The Prometheus language is really well known by the community in general, especially on the SRE side of things. And Grafana Loki uses LogQL, which is based on that same kind of query language. Okay. Now, the aspect of building an observability architecture can be pretty daunting, right? It's first a scale, right? Having, for example, you can spin up the demo environment, and it's gonna be great for a POC. I know persons that are using it for an MVP, right? A minimum viable product. But it's great for showcasing and actually seeing in action what's going to be the value that you're going to be able to get. Okay. But when you talk about scale, it's a whole different game. The management overhead. So now, do I need to start managing now all of this? Okay, all of these components, all these technologies on the skill set. Now, do I need to learn how all of these things now operate? So this is why the modular framework is the key aspect here, right? Especially on the networking aspect, I can guarantee you that your company, from a systems perspective, SRE, cloud, already have some of this observability already deployed, be it Influx or Prometheus or something around those lines. You can leverage that. You can actually be a customer of that team, okay? Or if you have enough budget, you can actually go with a cloud solution or an specialization to actually build it for you. That would be great, okay? But the main thing here that I want to highlight is that basically is here on the network engineering community industry, we know the data of the device. We know what happens with BGP, with VXLAN. We know about P2P. We are the ones that actually know how this data is going to be collected, how this data should be exported, because we know we should be able to understand also what is going to be putting stress on the device as well, in order for you to actually look at it. So the aspect that I invite the community is more on getting to know more the data collection layer and hopefully even processing layer, because that's actually where our expertise is needed, okay? Um, and I know that we're a little bit about out of time. This is the repository for sure. So well, the slides are going to be available, so you can actually look at it. The book itself is a practical book. Is all the labs and all the chapters around data collection, all over to visualization and alerting, are based on the labs that are exposed in this GitHub repository. And again, if you want to see it in action later on today, just reach me out maybe. So, thank you.